All right, so we're going to take a look at how to multiply a rational expression. Let's go back to something that you've completed before where you were looking at or where you were asked to multiply two fractions. So let's say that we have here 5 over 2 times y over 7. Well, to multiply fractions such as this example here, we will bring together our numerators and then bring together our denominators by multiplying, and we will have 5y over 14. So going back to the original definition for multiplying fractions, this is what we would use. Numerator to the numerator, denominator to denominator that we're multiplying. But since we're looking at multiplying rational expressions, we have to first factor the numerators first, then factor the denominators next, and then we'll cancel all pairs. And lastly, we'll bring together the numerators and denominators by multiplying. So let's take a look at one example where we have here 40x minus 24 all over 5 times 10 all over 3 minus 5x. So we want to factor the numerator, factor the denominator, factor the second fraction numerator, factor for its denominator we're going to factor. So the key to simplifying a rational expression is by factoring. So let's look at the first fraction numerator, 40x minus 24. Is there a GCF that can be factored out? If so, what? And it is an 8. So we have 8 times 5x minus 3 all over 5. The 5x minus 3 we can't do anything to, so we were able to, for the numerator, is factor out a GCF. Times, and then we have 10 over 3 minus 5x. The numerator of 10 we can't do anything to, but let's look at that denominator, 3 minus 5x. Remember, we want our terms to be in descending order. So switch the terms around. And then what we will have to do is factor out a negative GCF. So we're going to factor out a negative 1, and then we're going to have a positive 5x and a minus 3, because remember the signs are going to change. Now that each fraction they have been factored, let's cancel. Remember, when we cancel, the binomials or the pairs that we're canceling out do not have to be right under the other. It says as long as it's common to the numerator and denominator, the pairs that we're looking for, then we cancel them out. So we can cancel out the 5x minus 3, and then we're left with, in the numerator, 8 times 10. Our denominator, we have 5 times negative 1. And I noticed here with just our integers, we can divide the 5 and 10. 5 goes into 5 once, 5 goes into 10 twice, and then we have 16 over negative 1, which reduces to negative 16. And that is our answer. Okay.